All right, so using it here, it's a little bit more complicated for two reasons. One, we have a minus sign, so that changes things up a little bit. And also, we have a number. We don't have just a variable. We still have to use Pascal's triangle. So we're going to be 1, 1, 1, 1, 2, 1, 1, 3, 3, 1. This will be my exponent of 3. So I'm going to use this row here. And so let's go ahead and start it out just like we would if this was a variable, but instead it's a 2 now. So we're going to have x cubed plus, we'll go 3x squared, and then times, that's a minus, so times negative 2, plus 3x, and then times negative 2 squared, and then plus 1x, which will go away, and it's going to be negative 2 to the third. Okay, so now we need to simplify, so we have to do another step here. There's nothing that can simplify here, so it's going to be x to the third. But here we have 3x squared times negative 2. Well, that's going to be negative 6x squared. Here, this turns into 4, so we have 3x times 4. Well, that's 12x. And then here we have negative 2 cubed. Well, that's negative 8. You'll see if you'll notice that as we do these, every single time you have a minus sign here, your signs out front here always alternate. Plus, minus, and you always start with a plus. So instead of worrying about plugging in a negative 2 there, you could always plug in a positive 2 and then just go back and change your signs later, knowing that they're going to alternate. Here it's a plus, so we're not going to alternate any signs, but I do need to add another row to my Pascal's triangle. So there's that. So here we are going to have x to the fourth plus 4x to the third, and then 3 to the first power, which again we don't need to write, plus 6x squared, and then 3 squared, plus 4x, and then 3 cubed, and we have plus 3 to the fourth. And we can go ahead and simplify that. So we're going to have x to the fourth plus, this is going to be 12x cubed plus 9 times 6, that's 54x squared. 27 times 4, I don't know. 27 times 4 is 108, plus 108x, and then plus 3 to the fourth, which is 81. So there, that is expanded. The thing that's nice about this method is I know on your SLO and some of the questions you're going to do, it's going to say what is the fourth term of the binomial expansion. So you don't have to actually simplify everything. You can just say, okay, 1, 2, 3, 4. Here's my fourth term. So just simplify that and you can answer it that way. So that makes it kind of nice for those questions. Now this is the one I said, oh my gosh, is that even possible? Well, let's see if we can use binomial theorem doing this. So let's extend Pascal's triangle to as far as we need it. So I'm going to have to go another row here. 1, 6, 15, 20, 15, 6, 1. Okay, so there's my Pascal's triangle row I need. And then let's expand this out. Now here we have to be careful because it's going to be 2x to the 6th. It's that whole term. So 2x to the 6th plus... Then here I'm going to have 6, and I'll have 2x to the 5th and negative 2y. And then plus 15, 2x to the 4th, and then negative 2y squared. And then I'll have plus, I'll go ahead and write it down here, plus 20, and then it's going to be 2x to the third and negative 2y to the third, and then plus 15, 2x squared and negative 2y to the fourth, and I'll have plus 6, 2x times negative 2y to the fifth, and then plus 1, 2x, no, that's 2x to the 0, so that's gone. But negative 2y to the 6th is not. Now, having all that written out, I can simplify each term and easily come up with what that is multiplied out. So 2x to the sixth, well, 2 to the sixth is 64, so it's gonna be 64x to the sixth. And then plus, nope. I'll wait for the sign until I simplify. So we'll do 2 to the fifth, which is 32. So I have to multiply that by 6 and by -2, which is negative 384x to the fifth y. Plus, okay, I want you to try to finish this out on your own. Finish simplifying the rest of that. And we'll talk about that in class tomorrow when I grade your notes.